Okay, your physics problems from October the whatever. Today's the 16th of October, Sunday. I'm going over these problem solutions. One, so that you guys can see some examples of these projectile motion equations and just the problem-solving approach being used. Also, these are taken from a different textbook by John Mays, and while there are answers, there are no explanations in his book, and so it would be useful for you if I put these together. Anyway, so let's get started. I've got a dishwasher and a dryer running in the background. Hopefully it is okay, and my lighting is not the best. It's overhead, so you're seeing the shadow of the camera. But number one, batter pops the ball up. Alright, so straight up and then back down. We know its initial velocity is 67.01 meters per second. So that's v naught. We want to know up at the top how high up it goes, how long that takes. That's what we want to figure out. And we know at the top our final velocity there is 0. So, let's think about what we can do. First, we know that the acceleration in this situation is gravity, 9.8. And in fact, for the sake of significant digits, we can use 9.80 meters per second squared. It's actually somewhere around 9.8066, but for the sake of ease, we'll just use 9.80. And that way you just have to remember 9.8, but then remember that that's actually counts for 3 significant digits. Alright, so how long does it take for gravity to bring that to 0? Well, we can use one of our equations, which is that our change in acceleration, or the difference between our final and our initial velocity, is equal to the effect of acceleration over the course of time. Alright, so then we know this is 0 minus 67.01, and since I'm running out of space down here, I'm going to go ahead and we're going to divide both sides by 9.8. And that should give us our time. So, pulling out my handy-dandy phone calculator, I get a time of 6.838 seconds. Keep an extra significant figure there, so we've got that part of our problem. And for our answer up here, I'll go ahead and round to 3 significant digits. Alright, but now let's find the distance. So for the distance, remember, constant acceleration, I know an initial velocity, I know a final velocity, which is 0. In that case, the distance is simply the average velocity. So 67.01 plus 0, divided by 2, times the time that I now know. So plugging those in, .838 gives me 229 and some change meters, but that rounds to 229. Alright,